Hey, welcome back. Today on my bench I got a Harman Kardon HK 495i receiver. It's a nice little unit. It's nice and slim. This is eBay junk. It's missing a foot, as you can see, but I already have a foot left over from it was a 550 VXI, and they are the same feet, so I can just pop this in and we're done. That's fixed. But I just want to check it out. The seller said there was nothing wrong with it. It works fine. I just got it at a good price, that's why I bought it. But let's check this out together. I have it set up for speakers 1, and I got no left channel. Well, the left channel's there, but it's just fighting to get through. So, and we have no antenna hooked up anyway, but let's try the local station. Yeah, it's no antenna. So, looks like we have some cleaning up to do here. Either it's a bad solder joint. Sounds like a bad solder joint. Let's try this again. Could be a dirty pot, but we'll clean it. And we'll check out the rest of the unit. Yeah, I don't expect to find much wrong with it. Let's take the top off, we'll have a look. But before I open it up, just go over a quick overview of what it features. It has 2 speaker systems, basic, bass, treble, balance, volume. It has 2 tape monitors, and has phono, an input for video or CD, AM, FM, and that's pretty much it. Subsonic filter, stereo mono, and seek, scan, switch, the tuning buttons. Pretty basic. And the back is just as basic as the front. 2 courtesy outlets, 2 speaker outlets. It's got 1 phono input, 1 input for video CD, and then it's got the 2 tape 1, tape 2. It's pretty sparse on inputs as well. Like, I guess it's just a budget receiver. AM FM antennas. It looks nice and clean. Looks like a low hours unit. It's got those dreaded TK caps though. I might have to go through and check some of those. It's got a removable bottom, that's good. I'm going to pull the bottom off and ESR all these caps. There's not too many of them. And make sure, I'll check this pot here. See if that's got a cracked solder joint. So let's pull the bottom off as well. So the bottom of the boards look very clean. Nobody's been in here before me. Nobody's done any repairs or any replacement of parts that I can see. Everything looks original and touched. I'm not finding any cracked solder connections. There's maybe one here on the treble pot, but the other pots, they look okay. And some of these driver transistors, they're starting to get that fine crack line that's around the pin, but they're not cracked yet. So if I leave them alone, they will get cracked. So I'm going to touch those up. Yeah, there's really not much to talk about here. There is not much going on. Let's see if we can get that pot cleaned and that channel working again, that left channel. Okay, I got a tone generator hooked up. The left channel still cutting in and out. Right channel's good. So let's spray some stuff and see how this stuff works under while it's powered on. Wow, that pot's really messed up. I don't know. Maybe I can't resurrect this pot. It's too far gone. I might have to remove it and open it up. Can't. It's just that one channel. It's like there's something wrong with maybe something wrong with the wiper inside. The right channel's fine. All the other pots are fine except for that left channel. Okay, well, let's take that pot out. Alright, let's open this up and see. It looks like a fairly standard pot. It's Alps, made by Alps. It's a 50k ohm dual pot for stereo. Doesn't seem like there's anything special about it. Let's just see. I think I looked at the printed circuit board, and I believe the left channel is at the back here. So I'll just take the back off. Lift these tabs. And we'll have a look and see what's inside. Why it isn't working properly. All I'm gonna do at this point is I'm just gonna clean it with alcohol, and then I'll reassemble. But first I'll a little bit of carbon off there, a little bit of wear. Just dry this off. You can see it's constructed as a balanced pot because this part here, there's probably no resistance, and then all your 50k ohms is on this side with the carbon pad. Or maybe I got that backwards. No, that's right, I think. This is probably 0 ohms here. That's one way to check. Okay, so we should have 50k. That's good. And if I test here, we still have 50k. If I test here, we've got very low resistance. Just, let's see here. Is this side easily removable? No, it's not. Because that's stamped on the shaft. And even if I remove that, I won't be able to clean some deoxide fader. Even that's too much. Okay, I'll put that back in. Alright, so I've been going through with the ESR meter, checking caps, and I'm not liking what I'm finding here. A lot of these caps, especially in this power amplifier, you know, some on the tuner board, they're 40-50% of the caps in total are checking bad or below spec. And these are those TK caps that I've talked about before, and I'll talk about them again and again and again because they keep coming up. Yeah, I'll just take them all out. This thing's built 1987. It's 33 years old, and I'll just do a blanket recap. There's not that many here, and they're all small ones, so it's not going to be an expensive job. I'll test the main capacitors and see what capacity they have. I'll remove them and test them on my other capacitor bridge, and they're 8,000 microfarad each, and we'll see how those are. And if they're bad, I'll drop a couple 10,000s in because I think I have some here. But yeah, I'm gonna go through and start changing these caps. Okay, I wanted to show a bit of what I found with regards to the capacitors. I think I changed out 31 capacitors in total. These ones were borderline. I'm not going to test those. I did test them, but they're borderline. But I'm just going to show you a few of these that came up out of the receiver. Let's see here. We have these 47 microfarad 50 volts. There was a few of these. I think there should be 4 of them. 1, 2, 3. I think I'm missing one. But one, these were in the audio amplifier. And I'm just going to show you a few of these, how they tested. This one's 47, and if you can see up there in the right corner, there's this one is measuring 37 microfarads, 1.8 ohms, and that is over the allowance for ESR. And let's try this one. What's this one? 33 microfarads, 1.9 ohms, another bad one. And you got to appreciate these are in the power amplifier circuit, so we don't want these. Another 33 microfarad, 1.9 ohms, and the ESR on these should be, what are these, 50 volts? Should be around 0.5 ohms, so the ESR is probably 4 times what it should be. Here's another one. This is 100 microfarad. We're down to 68 microfarads. The ESR is just over acceptable, but it's still below or I should say below acceptable. This one's 67 microfarads, 8.82 ohms. That's below acceptable. 77 and 0.6 ohms. That one's not bad, but it's down in the microfarads. It's 20% down out of spec. Here's another one, 80. 8530. Okay, I want to check some of these. Some of these 10 microfarads are really bad. Let's check. .8 microfarad, 22 ohms, and we should be having an ESR of 8 ohms, not 22, so that's way out. You got to appreciate that when you have a capacitor that is supposed to be 10 microfarad and is down to 6.2, and the ESR is, let's see, on this one the ESR is 4 or 5 times the limit. It's going to start affecting circuit performance. Here's another one. 5.3, 21 ohms ESR. I'm just going to go through these quick. 4.9 microfarad, 20 ohms ESR. Another piece of garbage. This is a 2.2, and it has 2.2 at 50 volts. Should have about a 9 ohm ESR, and this is up around 23, let's say. Another 10 microfarad. It's down to half its capacitance and more than double its ESR. 6 microfarads and 14 ohms, that's no good. 5 microfarad, 20 ohms, that's no good. Six microfarad, 19.5 ohms, that's no good. So this one here is a 1 microfarad, but it measures 2.5, which is 2.5 times what it's supposed to be. But the ESR on this should be around 15 or 16, and it's up at 27. That's why I changed that one. And the last one is 5.3 and a 16. So you can see we definitely have failing capacitors in this receiver. So what I did is I replaced a few more than just the bad ones. I replaced the majority of the larger ones, and I went through and checked, and there were still a number of them that were acceptable, so I left them behind. But just to show you that where these bad capacitors are lurking. Okay, so I got it all back together. What I want to do is bench test the amplifier, see what the power output is going to be like. It's rated for 45 watts a channel, and I'm looking at this little wimpy transformer here. I don't know if we're going to reach that. We should be able to reach it, but I have a feeling it's going to get really hot because I don't see a lot of heat sinking going on here. But forget that. Before we start, I want to set up the bias, the idle current. And I don't know if you can see in the top left corner there of the screen, there is my 5.5 digit voltmeter there, and it's measuring 22 millivolts, and it's supposed to be 38. So we're going to tweak this a little bit to get it up, and we're going to do, I think it's the right channel. I don't know, they're not marked. I'm going to do this channel first, and we'll see if we can get that closer to 38. Oh, another note. Right now, it's been idling for a while. just to get it to warm up a bit. It's slightly warm. The receiver is drawing 24 watts total from the power. I got a watt meter in line with the line cord. So 24 watts, keep that number in mind. I'm going to turn up the idle current on this to bring it up to 38. Oh, wrong way. Let's turn it the other way. It's going down. Why is it going down? Okay, well, let's turn it the other way then. 38. There's a little too much. Okay, 38.5. Alright. Let's switch channels and we'll do the other adjustment for the other side. And what are we measuring on the other side? 22 as well, so we are pretty balanced. Let's turn this one up. $38, right there. Nope. Come on, down a bit. 37.5, close enough. Okay, so I got these both tweaked in, and now our amplifier is drawing 26 watts from the on the watt meter. So it's increased a bit. So what's going to happen is there's going to be an extra 2 more watts of dissipation going on here in these output transistors. So what I'll do is I'll let this stabilize for 15-20 minutes, and then I'll come back and I'll check the bias settings again one more time, just to make sure that they didn't drift off, because as this warms up, that bias setting will drift. Okay, so I'll let this sit for 20 minutes, and then I'll come and check these again. Okay, I'm back 15 minutes later, and as you can see, the voltage has changed. We're up at 44 volts now, or 0.44 millivolts, sorry. And I never touched the receiver at all. It's just, it's warmer. It's a lot warmer now. And we are drawing 27 watts on the mains power. So we've gone up that 3 watts from the room we originally started, and these are getting warmer. The thing you got to remember is, when you turn up the current for the idling current, the current through the transistors increases, which in turn causes heating. And as the transistors heat up, they conduct more current. So it's a thermal runaway scenario. So what I'm going to have to do is go down here and tweak this one more time. We want it at 38. So turn it down a little bit. Let's get to that channel. Let's move over to the other channel. And we're at 45 on this channel, so let's tweak this one down a little bit too. So sensitive. Hey, right there, 38 point something. And I'll let this sit for another 15 minutes, and then I'll check it one more time just to make sure it should stay on the 38 now that we've got the amplifier all nicely warmed up, and we got the idle current set for what it's supposed to be at operating temperature, so it should stay. It might drop a little bit if this cools off, but I have a feeling it won't. We are still drawing 27 watts from the power. Okay, now let's sit for another 10-15 minutes, and you can see it's around 38, 39. I made a mistake when I read the service manual. I thought it was 38, but it's actually 36 millivolts. So I'm just going to turn this down a little bit, just for the sake of accuracy. Just going to turn this down to 36. And I'm going to leave it at that. Let's do the other channel. As you can see, it didn't drift far from the last time I adjusted it. Okay, this one's at 37. Let's turn this down a little bit. These pots are wired, and one's wired in backwards, so when you turn it counterclockwise, that goes up. Okay, I'm going to leave that alone. That's good. Now, another thing I wanted to check while I'm here is I am just going to check the DC offset on the output. So I'm turning on speaker 2. Turn this sideways here so I can measure off the probes. So on the right channel I got about it keeps going up and down, between 17 and 21 millivolts, which is acceptable. And on the left channel I got negative 13, 12 millivolts, and that's also acceptable. So we're good that way. Let's put on a load, put in some signal, and see what we can get out of this thing. Okay, I'm all set up for doing power test here. Let's try this. Turn it on and we'll wait. There we got our soft start. Now I'm feeding it 1 kilohertz. Let's turn up the amplifier. Use the right clipping there. And I'm not getting a reading on my voltmeter. Why is that? So right clipping there. Clipping on the both channels. And I'm getting 20.1 volts RMS on 8 ohms. The amplifier, the receiver is consuming 157 watts. It's 45 watts a channel. So that's 90 watts output. And the remainder is what's used up in the heatsink here. Losses in the power transformer. So I'll let this cook for a while. So the heatsink's staying pretty relatively cool. It's not getting hot. It's been on like this for a few minutes now. This, on the other hand, my load is getting quite hot. I can't even put my hand on it. That's 100 watts going into that right now. And this is staying relatively cool, which is a good sign. So this is still, I can put my hand on it, it's getting probably around 60 degrees Celsius, but this I can't even touch, it's too hot. It's probably up around 80 or 90. Diodes are getting hot. I don't know why they went with those big diodes. They could have put a bridge in there. Drivers are running cool. That's good. Everything's good. I just want to point out my load resistors here, I don't know if you can see this. This one here's got a short to ground to the chassis. Last time I used this dummy load, I was pumping like 600 watts into it, and I guess I must have smoked this one resistor because it's now shorted to the case. So I have to be aware of that when I'm using this on future tests. We're close to running at 10 minutes at full power output, and this is starting to get relatively hot. This side's hotter than this side, not by much. You can tell there's a little difference there between the two. That's starting to get hot, and this is beyond touching that. So I'm going to shut this down and call it success. Okay, I believe I have another problem here. I was playing with the tuner and I was trying it out, and the AM band was really suck. So I went through and did alignment on AM, and it brought it back in, and it's picking up stations good now. The FM is another story. I have FM, it's able to pick up stations, and I'm able to scan through the band and pick up all the stations, but there is no stereo. It refuses to go onto a stereo mode, and doesn't matter, signal strength doesn't matter. The signal generator, I'm feeding it a 19 kilohertz pilot tone, and it doesn't pick up the stereo beacon. So I think I got a problem here with one of these two things. There is a chip here. It's a LA, what is it called? LA3410, and that is the chip responsible for demodulation. And it has a local oscillator, a voltage controlled oscillator, and I don't think it's running, to be honest. I can't see anywhere where there's a tone on here for the demodulation of the stereo. Now it could be the chip itself, or it could be ceramic resonator that's attached to it. It's 456 kilohertz resonator, and what they do is they divide it down by 12 to get you 19 kilohertz. Divide by 24, sorry, my mistake. But something in this circuit is not working, and to be honest, I don't have the ambition right now to troubleshoot this. I don't have any chips in stock. What I'm going to have to do is look through my chips and see if I do have one of these. I haven't updated my inventory in a long time. And I'll check to see if I have another crystal resonator. Between the two of them, I think that's one of the problem lies. I did change one cap in this circuit, and there's 5 other caps that I could change, electrolytics that I didn't touch. I'll give another close look at those to make sure it's not one of those, but I'm pretty darn sure it's the chip itself that's not oscillating, or that portion of the chip is not working. And just going through the block diagram of the chip, I don't have it here with me. It just scoping out the pins, and there's just nothing there. So I'm just going to close this up for now, and I'll deal with this another day when I get more patience. But for now, it's done. We did our power test, and everything worked fine there. Everything works good on the amplifier itself. We just got to fix that FM issue, and I'll put a note on this, and we'll do that at some later date. Alright, well, thanks for watching.